So we looked at how we can use substitution and composition of functions to create new power series. Sometimes it's not quite that simple. And so what is interesting is that power series can be multiplied and divided just like polynomials. So after you find the first few terms, then you might be able to recognize a pattern that you can go through from there. So here is our first example. We want to find the first three non-zero terms in the Maclaurin series for e to the x times the arctangent of x. Now notice they didn't ask us for the general term here. Sometimes these are going to get really kind of hard to figure out the pattern, so a lot of times they won't ask. And you'll see once we get working on this why they very specifically only asked for the first three terms, because trust me, that's plenty. So the first thing that we want to do is we want to write this out as the series for e to the x times the series for arctangent of x. And those are both series that were in the list in your notes of just the basic power series that we know and can use. So that's going to look like this. Okay, so once again, if you're looking at your list of basic power series, this is the power series for e to the x, and this is the power series for arctangent of x, okay? Now, I need to find the first three terms. Remember that when we multiply polynomials, we have to distribute through every time. So since I want the first three non-zero terms, I need at least those three terms. I may end up needing more, and we'll see what that looks like when we do. So we're going to start using essentially the distributive property to multiply all of this out. Now, I like to try to line my work up in columns. This is a place where you need to be really, really organized so that you don't lose track of stuff. So, when we multiply through, like I said, this is going to be like the distributive property. So I'm going to start with the 1, and I'm going to multiply 1 times x cubed over 3, 1 times x to the 5th over 5, ... So we essentially just get this series repeated because we're multiplying it all by 1. So we get x minus x to the 3rd over 3 plus x to the 5th over 5 plus ... Now we're going to multiply through by x. So this time we're going to multiply x times x times x cubed over 3, and x times x to the 5th. Now, I'm going to line up where I have like terms, okay? So x times x is going to make x squared. So that would kind of fall between these two terms. And then x times negative x cubed over 3 gives me minus x to the 4th over 3. And then I get plus x to the 6th over 5 plus ... And we're going to continue on with that. We need to get enough rows so that I'm going to have the first three terms, okay? Once I end up with a blank space underneath, I know that I'm not going to touch that term again. So right now, I know the first term for sure. That's it. I need to do some more rows to make sure. I need to get a blank space underneath this one, and I need to get a blank space on the next one to know that I am done. So now we're going to go through and multiply by the next term. So I'm going to multiply this time here, here, and here. So that's going to give us x cubed over 2 factorial. Then we get minus x to the 5th over 2 factorial times 3 plus x to the 7th over 2 factorial times 5 plus ... And if we think about what the next term was going to be, if I multiply by this x cubed, I'm going to end up with an x to the 4th. So now I know that I'm only going to be getting numbers bigger than these. So I'm going to have enough to get my first 3 terms. So now, and this is why I've been organizing my work this way, I'm going to just add everything straight down. So the first 3 terms, we get x plus x squared plus x cubed over 2 factorial, aka, oops, no, hold on. That's the right answer, but here's why. We have to add these, oh shoot, that was an eraser, sorry. X cubed over 3. We have to add these 2 terms together. Okay, so maybe let's come over here and do that. We have to add x to the 3rd over 3 plus x to the 3rd over 2 factorial, which is just 2. So when we add that together, oh, and this first one is negative, sorry. So we need to find a common denominator. So this becomes negative 2x cubed over 6 plus 3x cubed over 6. And so that all comes out to just be 1x cubed over 6, which is why that is the correct answer, x cubed over 6 plus ... But those are our first 3 non-zero terms in the series that we were asking for. So you can see pretty quickly how these can get real messy real fast, okay? So that's what it looks like if you have to use multiplication. It's just like multiplying polynomials, but the terms are going to get kind of ugly and the denominators are going to get kind of gross. So just take your time, have some scratch paper, be organized with your work, really space stuff out. If I was being a little bit more proactive here, I probably would have left myself a little bit more space between these terms, just knowing that I've skipped a value when I go from x to x cubed, that I didn't leave space for an x squared. It's nice to leave yourself a little bit more space. Okay, let's look then at an example where we could use division. So we can divide polynomials just the same way, which means that we are going to be using long division with these infinite series, which again can get a little messy. You just have to go slow and keep track of your work. So we want to find the first 3 non-zero terms in the Maclaurin series for tangent of x, which is not one of the ones that we were given. Now, there's nothing I can multiply to make tangent, but I do know that the tangent of x is equal to sine of x divided by cosine of x. And based on the list and what I know about those series, that means that we are taking x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus ... Again, that list just came from our list of basic series that you have in your notes, divided by cosine of x, which can be written as 1 minus x squared over 2 factorial, which is just 2. I'm going to leave the factorial off since it makes it easier, plus x to the 4th over 4 factorial minus ... Okay, we need, again, the first 3 non-zero terms. So when we want to divide this out, we need to set this up as we would with long division. So what we are dividing by is the denominator. So we have 1 minus x squared over 2 plus x to the 4th over 4 minus ... divided into x minus x cubed over 3 factorial, which is 6, and then plus x to the 5th over 5 factorial, which I also know is 120, minus ... I went ahead and multiplied those out just because I know I'm going to have to combine some like terms, and it might make it easier if I have the denominators already multiplied out. Oops, I left the factorial off of here. So this first one here should have a 4 factorial, but 4 factorial is 24, so that might be an easier way for us to think about it anyways. And so that's what we're doing. So if you need a little refresher on long division, remember the only thing that we do is we compare the first term with the first term. So 1 times what is equal to x? And the answer would be x. And so you always line up your like terms. So x goes above the other x. And now we're going to distribute that to the outside polynomial. So when I multiply here, we're going to put that underneath. And again, line it up with its like terms. So I get x times 1, which is x, times x times negative x squared over 2 gives me negative x cubed over 2. And then I get plus x to the 5th over 24. And so now we need to subtract that. So that is going to switch all of our signs. That makes this now negative, this now positive, and this now negative. I like using those circles when I'm taking notes because that helps me remember that I changed that sign. It wasn't already written there when I took my notes. So that's what I like to do. Oops, I forgot my little dot down here because that's going to keep on going. So, again, we compared the first terms, we got our value, we distributed, and now we need to subtract that polynomial, so that's why we flipped all of the signs. If we've done this correctly, that should cancel out our first one, which it does. Now we need to do negative x cubed over 6 plus x cubed over 2, which to get a common denominator here, this would be 3 over 6. So when we subtract, that gives us 2x cubed over 6, which is x cubed over 3, minus, when you do common denominators here with your x to the 5ths, you should end up with x to the 5th over 30 plus ... Okay, now we look at this again. And so we reset. And so once again, we are going to compare first term with first term, but this time we're looking at our new line. And so 1 times what makes x cubed over 3? Well, it has to be x cubed over 3. And again, you can see how that lines up with its like term right there. So that's nice. Now this time we're going to distribute x cubed over 3, x cubed over 3, x cubed over 3, like that, okay? So when we do that, and I really only need as many terms as I've got here, we're almost done. So now when I distribute, I get x cubed over 3, and then we get minus x to the 5th over 6. All right, now again, we're going to flip all the signs because we want to subtract that polynomial. Our first term zero out, which is good. And when you find the common denominator and simplify, you end up with 2x to the 5th over 15 here plus ... Okay, now think about what our next step would be. Compare the first term with the first term. Our next term then would have to be 2x to the 5th over 15. And so that gives us our answer. This is all going to come out to be x plus x cubed over 3 plus 2x to the 5th over 15 plus ... That is what we get. These are definitely the least fun part of this section, I will acknowledge. These are very tedious. There's a lot of places to get lost, so don't get discouraged with these. Just work slowly, keep things lined up in columns, keep your work very organized, and I promise you will get the hang of it.